3.5, relations and functions. So in these sections, we're going to be introducing what is a relations and what is a function. Okay? So a relation is simply a set of order pairs. So um, in the previous sections, we saw that order pair as in x coordinate and y coordinate. But in a relation, it could be anything. So we will uh, reword it as first component and a second component of the order pair. Okay? So um, example one is given to you in set notation. So as you can see, this is braces and braces using set notation. So January $1, February -$50, March 10,000. So notice that it's not necessarily always a numerical order pairs. It could be a different, months, objects, or fruits, anything. Right? Any order pair is fine. That is a relation. Now the second example is shown to you in mapping diagram. Mapping, okay, diagram. So from this mapping diagram, you should be able to obtain the order pair as well. So as you can see, uh, the the arrow that's go which directions, that will be your first coordinate will be 1, and then it will go to what the second coordinate, which is 5. So that's an order pair. 2, 6, 3, 7. So those are the order pair, but this is presented in mapping diagram. And another example is showing you in graphical format. Okay, this is the graph of a relations. So a lot of uh, order pairs put it together and then connected will become a circle in this case. It could be any other things. And there are a few things that a few more uh, ways to present it, these relation, but we don't have to worry about that much, okay, at this point. So all the first component of a relations is called domain, and later on we will basically talk about in rectangular coordinate system. So all the first components will become of order pair will become x values. So you can simply remember x value as domain, and the second components of the order pairs in the relations are called range. So later on you can remember that as y values are your range. Okay, so this is a definitions of relations and then domains and range. So next up is a functions. Okay, so what is a function? A function is basically a special type of relation. How's that special? Each first component corresponds to exactly one second component. So another way to say is each x value corresponds to exactly one y value. And once we continue on this function, we will use all the x value as the input and all the y value as output. So each input corresponds to exactly one output value. So let's take a look at on the example. Okay, so the first example gives you 1, 4, 2, 5, 3, 6, the order pair. So if you look at on a mapping diagram, you can see that 1 corresponds to exactly 4, 2 corresponds to exactly only 5, 3 corresponds to exactly 6. So therefore, this is a function because each x coordinate corresponds to exactly one y coordinate. So this is a function. Okay. And the next example, as you can see, 2 corresponds to 4 and then 2 also corresponds to 6. So this violates the definitions, which is one x value corresponding to two y values. So therefore, this is not a function. Okay, this is not a function. So in the set notation, you can clearly see that here's one x, but they have a different y value. That tells you right away it is not a function. Now, what about the third example? 1 goes to 4, 2 goes to 5, and 3 goes to 5. So for each x value, it's correspond to exactly one y value, so therefore this is a function. Since we're going to be graphing uh, equations later on, and you might want to, we want a preview of like what these three types gonna look like. And the first example, is very much look like a line that we draw on the previous section. See, if you look at a line, every x value there's correspond to exactly one y value. So this is a function. Now the second type, this is how it's going to look like. For example, a circle that I gave it to you earlier. This is not a function because for this particular x value, you have here's another y, here's another y value you're going to get. Okay? So therefore, this is not a function. And how about this one? The last one's going to look like two different x value go to the same y value. We will learn how to graph this once we talk about parabolas, quadratic equations. Okay, so the quadratic equations, which is parabola, if you take a look at it, is going to be going like this. So for this particular y value, I have here's another x and here's another x that's going to correspond to. See that? So those are the situations that we have. So let's take a look at an example, see if we really understand this or not. Okay? So example 1 asks you to determine whether the relation is a function or not. If it is a function, I want you to state the domain and range of it. So what is the functions? Every x value must correspond to exactly one y value. So this first example is giving you a finite relations because we have only 2, 4, 6 order pairs. And we have to make a transition from the finite case to infinite case very soon, like in next 3 example. So I will point it out, right? If you look at the x coordinates of each order pair, all of them are different. So therefore, each x coordinates correspond to a different y coordinates. So exactly one y coordinate. So I can say that this relation is a function. And therefore, we want to know what is the domain and what is the range. So domain of these functions will be the first component, all the x values. So it will be -3, -6. Oh, my bad. Sorry. -3, -2, -1, 0, 2, and 4. The range is all the y coordinates, which is -6, -4, -2, 1, 3, and 4. So that's a function. So second example, we have four order pairs, and we want to determine this relation is a function or not. So when I look at this, I can see the second order pair and the last order pair has the same x coordinates, and it has a different y coordinates. So that tells us one x value, it corresponds to two different y values. So therefore, this is not a function. This is not a function. Okay. Now, continuing this in a graphical format. So part C gives you 3 points, and notice that each point has a different x coordinates. So therefore, each x value have exactly one y value. So this is a function. So what is my domain? Okay, what is my domain? Let me write it in short, just D. What is my domain? Is all the x coordinates. So therefore, since it is a finite case, we will be using the set notation. That will be 1, 2, and 5. That is my domain. What about my range? My range will be also from these 3 points, which is going to be 1, 3, and 2. Remember, the range are the y coordinate of the order pairs. So the difference between this example C and example D are the finite and infinite case. Okay, so notice that the same 3 point, but this time I connected with a line segment to each point. Now, this is still a functions because every x value it corresponds to exactly, let's say here's an x value, it will be graph right here, and it will correspond to exactly one y value. So it is still a functions, right? Every x value corresponds to exactly one y value. So it's very easy to test. If you draw a vertical line anywhere, if the vertical line passed through the graph only once, then this is a function. Okay? So it's called a vertical line test. So we know that now it is a function. And what about our domain? In this case, it is not a finite as in the previous example. It's an infinite case. So what we need to do is we need to look at from 1 to 5. Every number between them is inclusive. Remember, because a line is made up with a lot of points. So here's our infinitely many points in there, right, on this line. So therefore, my domain will be every number from 1 to 5 up to the graph. So we write it domain in terms of interval notation, which is from 1 to 5, and 1 and 5 are inclusive, so it'll be bracket. So that's the difference between infinite case and then finite case. Okay, so range, similarly, if you understand that, my range will be every y values on the graph. So that means my y will be starting from 1 all the way to what? 3, because that the graph will always reflect it back into those, if you see that. So that will be my y, and my range will be from 1 to 3, and then those are inclusive as well. Okay, So that's the difference between the finite and infinite case. So let's move on to the next example, E. So let's put an arrow heads down here because I cannot put it on when I was using the program. So that arrowhead that basically indicate that the line's gonna be extended as far as you can. So that means you can see that if I draw anywhere a vertical line on this graph, the vertical line will only pass through one point on the graph. So that tells you it is a function because every x value corresponds to exactly one y. So we know that this is a function. And now, what is a domain? The domain of these functions, since the graph is going to be extending to the left and to the right, and it will cover entire x-axis as far as you can go, as far as the graph extended. So therefore, my domain is all real number negative infinity to positive infinity. Similarly, if you look at the other way around, the range, right? The range is talking about the y value. So if the graph extended, it will cover entire y-axis. Okay, so my range will be also negative infinity to positive infinity. Next, parabola. Put a arrowhead right here, arrowhead right here. Okay. So if you, like before, if you draw a vertical line anywhere on this parabola, you can see that the vertical line only passed through the graph once. So therefore, that tells you for every x value, it's only have what? One y. That makes it parabolas are a function also. Okay. So what about the domain in this case? My domain. So the parabola is not going straight up. It will extend it out to these directions and extend it out to these directions. So eventually, as far as you extend it out, it will eventually cover up the entire x-axis. So that tells me my domain will be from negative infinity to positive infinity because as far as the graph extended. Okay? So you rewrite in interval notation. What about the range? So the range is talking about the y coordinates of the graph, right? Y coordinates. So if the graph continue extending, it will go up and up. So it will be positive y values. It will cover all the up. But however, the graph is basically start from here, that point. So there's no graph below of it. So my y, my range, will be starting from -3 and continue going up. So it'll be to the positive infinity. So -3 is inclusive. So that's my y. See, the graph only cover the y values from -3 to positive infinity on this graph. So hopefully you are getting better and better with finding the domain of the graphs. Right? Next example. So this is a square root graph that we're going to learn how to graph around in chapter um, 8 also, 8 or 9. So, so if you look at this graph, and also put the arrowhead in this side because it's going to continue. And if you draw a vertical line anywhere on this graph, the vertical line only passes through one point on the graph. So that tells me for every x there is exactly one y value. So therefore, this is a function. And if it is a functions, we want to know how to get the domain and range of it. So let's talk about domain. Domains is the x coordinates, right? So if you look at the graph, and since the graph is extending onto the right side like this, so the x value will be continue extending on the right side. It will cover up the whole x-axis on the right hand side. But however, the graph never extended on the left hand side, so it stopped right here. So it's only covered the x value up to -4. So you notice that there is no graph after negative left hand side of -4. So therefore my domain will be from -4 to positive infinity, and -4 is inclusive, and then parentheses right here. Now let's take a look at on the the range, right? The range is the y values, right? My range is the y value. Since the graph is going to be extending, continue extending to the right and up, so my y value will be extended also on top, right, to the positive direction. But however, the graph never go down below 0. So see, notice at this point right here is the lowest point, which is y value of that point is 0. And we don't have any graph below 0 either on a y coordinate. So my range will be from 0 to positive infinity, and 0 is inclusive. And lastly, looking at the graph like a parabola, but however it is on a sideway. And this is not a function, because if I draw a line, you can see that for one x values, I have what, two different y values. So therefore, this is not a function. Okay, this is not a function. Now, lastly, what we want to do is we want to know how to evaluate the functions using the function notation. So some equations that we talk about in the future will be a function, some are not. Right? So we will learn how to determine that later on. But let's talk about function notation. Let's say I have an equation y equal to x plus 1. If I rewrite this into, we know that y equal to mx plus b, that is a line is a function. So if I rewrite in terms of function notation, that y will be represented by f of x, g of x, h of x, or v of t. Right? I can write in a different ways. But all of those are just a name of the function. And each functions is like a equations. We will have a formula on the right hand side. Okay, you have a formula or a rule on the right hand side. So now you know that how to rewrite from equations to functions. So we know that this function notation f of x, that basically represent the value y in order pairs. So this entire notations f of x, 1, we call it function value. Which is the y value. Okay, which is the y value. And 2, we call it output value. And 3, we call this range, right? Because all the output value together, all the y value together is range. And lastly, this is also known as dependent variable. So those are the terminology that you will mostly see in your textbook and a different textbook. So what about the x by itself on this function notation? We call this x value. Right? Corresponding, but this is very less to use. Certainly to use this uh, in term, but the second one is mostly used, which is we call it input value. And the third, we know that all the input value together is called domain. Okay, and lastly will be independent variable. Independent variable. So now what we want to do is we want to know how to evaluate these functions. So if I ask you to find f of -1, that is basically asking you to find what is the output value when the input is -1. So basically, this is how I want you to write this, f of -1. So we're going to be substituting this input value for every x in the formula. So that will be input square minus input. So -1 and -1, because the formula for the f function is x squared minus 1. So when I compute this, this will be -1 squared is 1, -1, negative of -1 will be +1. So therefore my final answer is 2. Not necessarily all the time um, the question will ask you to evaluate a specific integer, right? A specific input. It could be in general also. It could ask you to evaluate an expression. So like in second example, now we are evaluating f of what? 2x. So you're going to be substituting 2x for every input in the formula. So this is, so notice that it's very confusing. Like, you have 2x and in the formula it has also x's. So this is how I want you to read it out loud, and then make sure you get used to with the notation. So f of 2x. So that will be the formula of f is basically input square minus input. Make sure you read it that way. Okay. And what is my input in this problem? My input is 2x. So I will substitute 2x, my input, 2x, my input, into the formula. So when I square it, it will become 4x squared minus 2x. That will be my final answer. And moving on to the next example. Now I ask you to evaluate g of x minus 2. So in this case, my input is x minus 2. So we want to evaluate g of x minus 2. So what is the formula of g function? So the formula of g function is right here, right? So it will be 2 times input plus 3. That's the formula of g function. So what is my input? X minus 2. So when I simplify this, this will become 2x minus 4 plus 3, which will become 2x minus 1 after we simplify it. And finally, the last example is asking you to evaluate f of 2 minus g of 3. So basically, you are subtracting two output values from two different functions. So in this kind of situations, to make it nice and neat on the computations, we will work on the side work separately. f of 2. So let's evaluate f of 2 first. So that will be equal to, the formula of f is input square minus input. So what is my input? That is 2. So it will be 2 square minus 2, which will become 4 minus 2. The result is 2. So now we write it, the result, f of 2, the answer is 2, minus, now we have to find out what is g of 3, right? G of 3. So what is the formula for g functions? That will be 2 times the input plus 3. So my input is 3, so 2 times 3 is 6. 6 plus 3, that is 9. So now I know that the function value, the output of g of 3 will be 9. And when we subtract these two output values, I get negative 7. And that will be my final answer. And that concludes this section.